A vending machine is a machine that dispenses small articles such as food or drinks when a coin or bill is inserted. The project tries to replicate the behavior of a vending machine while using logic gates. There will be buttons that, when are pressed, show a character on a display, and when a couple of buttons are pressed and the sensor of the money compartment is high, then the corresponding output will be high. The project has the following requirements. The machine has to read if the user has already introduced an amount of money. Also, make a selection of a number and a letter by pressing the button which will be labeled. Show on the 7-segment displays the selections. If two characters of the same kind, such as two letters and two numbers, are selected, then mark an error on the display. When a product is selected, produce a high at the corresponding output, which will be labeled with the number and letter. As we can see on the basic engineering diagram, we have three components that are connected to the integrated commercial circuits, which are the core of this simulation. These circuits are connected to two outputs, which are the motors of the products and the 7-segment displays. The coin detector is a sensor which will produce a high when a coin is detected. The power supply is a device that creates a current so the electronic components would work, and the buttons are the level inputs, and a combination of them will turn on the correct output or the correct motor. The integrated circuits, as I mentioned, is the core of the simulation and are basically the 74 LS components. The motors are the parts that will rotate in order to drop the product, and the 7-segment display will show the user the current selection of the inputs. For the detailed engineering part, we have to see the truth tables and Karnaugh maps which are on the report. From there, we we can get the the diagrams and gates that need to be used in order to make the 7-segment display work. So from the truth tables, we can we can start designing our diagrams, which, as you can see, all of them are connected to the 7 inputs for the 7-segment display. We also have 6 inputs as buttons and 1 input as a coin sensor. And in order to make a vending machine work, we have the outputs as motors, that all of this, which are 9, and one of them is a combination between a number and a letter. So, for example, in order to make an input work, we choose one number, which are the left ones, and one letter, which are the right ones. For example, I can choose a number 3 and the vowel or letter E. So in the 7-segment display, I have the 3 and the E. And on the outputs, I have one high, which is this one, and is the correspondent output for the two inputs I selected. Well, if if I have a selection and my input of the coin sensor is low, then the 7 segment display will show an error and the all the outputs will be low. And for the last part, I wanted to show what happened if I choose two letters and or two numbers. Then the 7 segment display will show an error as well, and the outputs would be low. In conclusion, this project was the integration of everything I've learned during the course. At the beginning, I had some problems because I didn't remember how to make the combinational logic, so I took out my notes and remember the truth tables of the 7 segment displays. I also learned how to make a mechatronics project and what's the correct procedure in order to achieve the objectives planted in the requirements. And also, even though I didn't use it, but I learned about the incomes and the times that we have to respect in order to make a mechatronics project work.